So let me actually. Okay. So when we're doing law of sines and law of cosines, we need to be able to identify which one we're getting. And if you can see that there's some pairs going on, then we want to use the law of sines. And I'll show you the pattern for law of cosines, but this one's law of sines. And you can see right here that I've got one pair right there and one pair right here. Okay? And I have reminded you guys that whatever variable you have, you want to put that on top of your formula, okay? And so because my variable is a degrees, we're going to put the degrees on top. So I'm going to do sine of x. And what is the side that goes with my x?
23.
Okay. And that is, these are proportions, right? Okay, so then I want to do my sine of 27. And what goes with 27? Okay, so 11. All right, then I'm going to multiply this one up. So I get sine of x is equal to sine, oh, sorry. We're going to put this first. 23 times sine 27 all over 11. You can solve this if you want, but I'm just going to say that putting it all in the calculator will help prevent error. Okay, so I'm going to do the sine inverse of this whole thing before I put it in my calculator.
Yeah, because every time I put it in my calculator, it kept saying, no real answer.
Okay, so the problem is that you have to close these parentheses in your calculator before you can kind of move on. Okay, so we want sine inverse. So I'm going to do sine inverse 23 times sine 27, but close parentheses and then divide by 11 and then finally close your parentheses. You get 71.6, so equals 71.7 because, sorry, we want 3 significant figures for IB. Okay?
You're so smart.
Okay, now let's look at a law of cosines one. We can use, this is one of the patterns for a law of cosines, and that is the fact that I have all 3 sides and I'm looking for an angle. In here, okay. All right, so do you guys see that I don't have any pairs, right? I've got one pair, but I need 2 pairs to do anything. I don't know what the opposite of 12 is or the opposite of 11 is. I don't have that. So I'm going to be doing law of cosines. Okay, so first you need to, I like to use the Pythagorean theorem version because it's easier to remember. Right. They sometimes give you like 3 different versions, but honestly, the point is that the pair that you're looking for is that one pair that we have right here, okay? So I'm looking for this angle, and this is its opposing side, so this goes as C. Is that okay with everybody? The pair that you're looking for is sandwiching your formula. Okay?
Wait, say that again?
The pair that you're looking for is sandwiches the C and the C, right? Do you see the C's are sandwiching the formula?
Yeah.
So that's your, what you have and what you want. That's the pair that, sandwiches the equation, okay?
Okay.
So I can name this one A and this one B and this one C. This one is C because I'm looking for its opposite angle, okay?
Okay.
All right, so then I do 7 squared equals 12 squared plus 11 squared minus 2 times 12 times 11 times cosine of x. All right, so now we can start evaluating. So 144.
Wait, isn't it supposed to be 12 times 7? Because that's C. Or that's supposed to be 2 times 8 times C.
Okay, so I just have to make an error correction. This is 2 times A times B right here. That was my incorrect error. Okay, so 22. What's 22 times 12? Okay, so 264. Nope. Oh my god. Sorry. Okay, so now let's move everything to the other side. So 49 minus 144 minus 121. So 49 minus 144 minus 121. So that's negative 216 equals negative 264 cos x. And if you can see that, you're going to get cosine of x is equal, we'll just cancel the negatives out. So I get 216 over 264, or x equals cos inverse of 216 over 264. Okay, and we'll put that into our calculator. And so we'll get cos inverse 216 over 264, and I get 35.1 degrees. What did I get? 35.1 degrees. Make sure you have your degrees there because you don't want to forget that, okay?